Hello candidates, welcome back to Math with Trockers. So in today's tutorial, we are solving a polynomial problem. Mainly we are focusing on remainder theorem and discriminant from ZIMSEC November 2003. The question reads, given that a function of x equal to mx cubed plus m plus 2nx squared plus m plus nx plus 2 is exactly divisible by x plus 1, express n in terms of m. Then show that in this case, the equation f of x equal to 0 has only one real root. Then m squared minus 6m plus 4 is less than 0. 6 points. Okay, let's dive in. All right, so we are given f of x equal to mx cubed plus m plus 2n x squared plus m plus n x plus 2. So if something is exactly divisible by x plus 1, what it means is that, okay, so we have x plus 1 here. When we solve this, x is negative 1. So if we plug in negative 1, we must get 0 since x plus 1 is a factor. So now let's plug in. So it's going to be, if you plug in negative 1, it's going to be negative m plus negative 1 squared is positive m plus 2n here minus m minus n plus 2. We must get 0. So this and that cancel out. And now we have, okay, and now we have 2n minus that. That's 2n minus m plus 2 equal to 0. And we need to express n in terms of, sorry, this is n here. We need to express n in terms of that. So n equal to m minus 2, right? That's all for the first part. N equal to m minus 2. Then now, show that if in this case, in what case? In the case where n equal to m minus 2, and we are told that f of x is equal to 0, there's only one real root. But guys, let's go back to f of x. F of x is a cubic polynomial. So when we solve a cubic polynomial, we must get three real roots, right? But in this case now, we are only told that it only has one real root. Meaning say the other roots are imaginary. So now, remember the discriminant, b squared minus 4ac, right?
So guys, to determine the nature of roots, we use discriminant b squared minus 4ac. If it's greater than 0, the equation has two distinct real roots. When it's equal to 0, the equation has one repeated root or simply two equal solutions. If it's less than 0, the equation has no real roots or the equation has two complex conjugate roots.
Then that the remaining quadratic part, right, will be b squared minus 4ac should be less than 0. So here, when we have distinct and real roots, right, this will be greater than 0. When we have equal roots, it's equal to 0. When we have imaginary roots, it's going to be less than 0. So this is the concept. That's the part we are going to use because the other two are imaginary, right? So now let's see. So first, we need to say f of x. Let's replace m with m plus, remember, n is that. So 2 times that, 2m minus 4 x squared, then plus m minus 2, then x plus 2. Right. So here we are going to divide by x plus 1. All right, let me simplify first. So our f of x equal to mx cubed plus 3m minus 4x squared plus 2m minus 2x plus 2. Right, that's our function. So let's go ahead and use, I prefer long division here. So we're going to divide by x plus 1, and you're going to see that x plus 1 is going to be a factor, but we'll consider the quotient here. So mx cubed plus 3m minus 4x squared plus 2m minus 2x plus 2. So this into that, x into that, it's mx squared. This into that, we have got mx cubed plus mx squared. Then we are going to subtract, right? So when we subtract, this will cancel out, 3m minus that, so we have 2m minus 4, right, x squared plus 2m minus 2 x, right? Then we repeat again, this into that, it's plus 2m minus 4x. This times that, 2m minus 4x squared, then plus 2m minus 4x, then we subtract. So these two will cancel out. 2m minus 2m, the 2m's will cancel out. Negative 2 plus 4, that's 2x, and we bring down the 2. Then this into that, it's plus 2, right? We have 2x plus 2. Then we must get a 0 when we subtract, because that is a factor. So since if we solve, okay, allow me to rewrite it as f of x is now equal to, so we have our quotient plus the remainder plus the divisor. So here quotient here is going to, oh, let me just write it as x plus 1 times that, we have mx squared plus 2m minus 4, right, x plus 2, then plus the remainder here, right? Remember, if you want to write this function, it's going to be f of x is equal to quotient times divisor plus our remainder. All right. So now, if we solve, since it has only one real root, the answer is that one, right? Means that this quadratic factor has no real roots. So since it doesn't have real roots, we are going to use b squared minus 4ac is less than 0, right? Since the quadratic factor does not have real roots. So our b there is m, right? So it's going to be, our b is 2m minus 4 squared minus 4 times m times c is less than 0. So now if we expand here, it's going to be 4m squared, 4 times 2, 8, minus 16m plus 16 minus 8m is less than 0. Then that will be 4m squared minus 24m plus 16 less than 0. If we divide by 4, it's m squared minus 6m plus 4 less than 0, which is exactly what we are supposed to show. And that's all about this question. Let's continue to do more practice. I'll see you in my next video. Take care.